In this lecture, I'm going to talk about how to control the flow of execution within your blueprints. So I'm going to right-click on an empty space in the graph to bring up the node menu. And then under Utilities, there's a category called Flow Control. This category contains several different nodes that you can use to control the flow of execution of your blueprint logic. So the first node in the list is the branch node. The branch node takes in a Boolean value as its input and then continues execution either through the true output pin if the Boolean value is true, or through the false output pin if the Boolean value is false. You could directly set the condition to evaluate to true or false by having this checkbox checked or unchecked, so this is something you might do for testing purposes. But for practical use, you would hook something into the condition pin to be evaluated. For example, you could hook a Boolean variable into this pin. So I'm going to create a new Boolean variable called shouldGameQuit. And I'm going to give it a default value of true. And I'm going to connect that variable to the branch node as the condition. And then I'm going to insert the branch node into the flow here and connect the true output to the delay node. So what this does is it makes it so that if the shouldGameQuit variable is true, after a 2-second delay, the game will quit. But if shouldGameQuit is false, nothing will happen. Alright, so besides using a Boolean variable as the condition, you could use a node that evaluates a condition and then outputs a Boolean value. For example, if I wanted to evaluate whether or not two integers are equal to each other and use that as a condition, I can do so. So I'm going to right-click to bring up the node menu, and I'm just going to type the equal sign into the search box and then select the equal function. So now I have this node that takes two variables as its input and outputs a Boolean value of true if those two variables are equal and outputs a value of false if they are not equal. So let's say I had an integer variable named x and I wanted to test whether or not the value of x was equal to 5. To do so, I would just need to create a get node for my x variable and hook that into one of the input pins, and then hardcode a value of 5 for the second input pin. So now, if x equals 5, the game will exit. Otherwise, it will not. And if I wanted, I could have connected a second integer variable to test against instead of hardcoding a value in the second pin. After branch is the delay node, which we've already covered. So after that is the doIn node. This means do n times, where n equals the number of times this node should allow execution to pass through it before it begins to block execution. For example, let's say every time I pressed the key, it printed a message to the screen. And I'm going to cover inputs in detail later on in the course, so for now I'm just going to do this quickly. So now, every time I press the F key, it will print hello to the screen. And I can press F as many times as I want, and it will still print hello every time. But if I inserted a doIn node between these two nodes, I could limit the amount of times I could cause the message to be printed. So if I enter 5 as the value for n, the first 5 times execution flows into the enter pin, it will flow out of the exit pin. However, the 6th time and beyond that, the flow will not continue out of the exit pin. So going back to the game, the first 5 times I press F, it prints hello to the screen. But after that, pressing F no longer does anything. So execution will be blocked in a doIn node after the nth time that node has been activated, unless execution flows into the reset pin of the node. When execution flows into the reset pin, the counter will be reset to 0 and the node will be able to execute n more times. So if I connect a G key press to the reset pin and then compile and go back to the game, I can press the F key 5 times and print the message hello, and then the F key won't work anymore. But now if I press the G key, the F key will work again another 5 times. And finally, this counter pin will output an integer representing the number of times the doIn node has been activated since the game began or since the last time the node was reset. So I'm going to connect the counter output pin to the end string pin so that it will now output that integer to the screen instead of the word hello. And because this is an integer and this is a string and integers can be converted into strings, the editor automatically created a conversion node when I went to connect these two pins. Okay, so now if I compile again and go back to the game, as I press F, it will output the numbers 1, 2, 3, 4, and 5, and then it won't output anymore until I press G, which will reset the counter back to 0. So now if I press F again, it will output a 1 because this is the first time the node has been activated since it was reset. And as I continue to press F, it will go back up to 5 again. Alright, so next is the do once node. And this node is just like a doIn node where n equals 1. With the exception that with the do once node, you have the option to have the node start closed. By having the node start closed, this means that execution must flow through the reset pin before execution will flow through the completed pin even the first time. Next is the do once multi-input node. This is like the do once node, except that it allows for multiple in-out pairs. Additional pairs can be added using this add pin button at the bottom. So if execution flowed into the AN pin, it would flow out of the AOut pin. If execution flowed into the AN pin a second time without a reset, nothing would happen, but execution would still be able to flow through the B pins and through the C pins. And if execution flowed into the reset in pin, all of the pairs would get reset. The do once multi-input node also differs from the do once node in that it has a reset out pin that will be executed when the reset in pin is executed. Okay, so next is the flip-flop node. The flip-flop node simply alternates between having an execution flow out of the A pin or the B pin every time the node is activated. So the first time execution flows into the flip-flop node, the execution will flow out of the A pin, and the second time execution flows into the flip-flop node, it will flow out of the B pin, and then the third time it will flow out of the A pin again, and so on. So I'm going to hook up the F key press to the flip-flop node, and I'm going to have the A pin print the word hello to the screen. And I'm going to have the B pin print world to the screen. So as I press the F key, it should alternate between printing those two words to the screen. So if I compile and start the game, when I press F the first time, it prints out hello. And when I press F the second time, it prints out world. And will continue to do so back and forth as long as I keep pressing the F key. And then there's also this Boolean output called isA that will output a value of true if execution is being routed through the A pin during this go, and false if execution is being routed through the B pin. Alright, so I'm going to stop here for now so that this lecture doesn't get too long, and you can take a breather if you need it. And in the next lecture, we will finish the discussion on flow control nodes.